Good day everyone, this is Nika Kuskus again and welcome back to my YouTube channel. So let's discuss the ratio test. Remember the ratio test. If the summation of a sub n is a series with positive terms and the limits of n to infinity, a sub n plus 1 over a sub n is equals to the ratio equals to L or R ratio, then the series converges if the ratio is less than 1. Then the series diverges if the ratio is greater than 1, and the test is inconclusive if the ratio is equal to 1. So in root test, if the summation of a sub n is a series with positive terms and the limit of a sub n where n is equals to where n is the n squared of a sub n equals L, then the series diverges if the ratio is less than 1 and diverges if the ratio is greater than 1, and the test is inconclusive if the ratio is equals to 1. So it has the same rules as for the ratio test. Example, the summation of n equals to 1 to infinity n squared over 2n is equals to the infinity to the n squared of n squared over 2n is equals to n squared of n squared over 2, where the limit of n to infinity n squared of n squared over 2, which is 1/2. That means it is converges. Another example, the summation of n equals 1 to infinity 2n over n squared. Let's use the root test, where n squared of 2n over n squared is equals to 2. 2 is equals to n squared of n squared. Limit of n to infinity is 2 over n squared of n squared is equals to 2, which is it is diverges because the ratio is greater than 1. So thus the summation of n plus n equals 1 to infinity 1 over n squared of n converge. So integral of 1 to infinity 1 over x squared of x dx is equal to the limit of b over to infinity squared of, let's conclude that is infinity is b. Integral of 1 to b x is, evaluate this, which is -3/2 dx is equals to the limit of b to infinity minus 2x raised to -1/2 evaluated to 1 to b, where the limit is equals to the limit of b to infinity. It's a quantity of 2, meaning 2 over square root of b plus 2 is equals to 2. So since integral converges, the series must converge, but not necessarily 2, 2. So that's all for today. I hope you learned. Thank you.